Here's a famous problem that you see almost in every single textbook for how to find the zeros of a polynomial by factoring. The first thing I want to do is recognize this is 4 terms. So the best way to be able to approach that is going to be factoring by grouping. However, when I have my first 2 terms are separated by subtraction, rather than using subtraction, I want to change this to adding a negative number, right? Because adding a negative is the same thing as subtracting. Then I group my first 2 terms, group my last 2 terms, and now factor out the GCF from each of them. Between x to the 5th minus x cubed, the common factor is going to be an x third. So I can factor out x to the 3rd power, and that's going to leave me with an x squared minus 1. Now when I factor my second parentheses, I want to try to obtain an x squared minus 1. It's very similar. So all I simply need to do is factor out a negative 1. That's going to give me an x squared minus 1. Now factor by grouping is factoring twice. You first factor out the GCF of your first 2 terms, and then you factor out the GCF of these 2 terms, because again, they're separated by subtraction. Again, you recognize these 2 share a x squared minus 1. So now I can factor out an x squared minus 1, and left over is going to be a x cubed minus 1. Now I have a product equal to 0. So we can go ahead and use the square root method to go ahead and solve this. Add 1, take the square root of both sides. X is going to equal a plus or minus 1. Be careful doing that over here though, because if you add 1 and take the cube root of it, you're only going to get 1 solution. Since this is a polynomial to the 5th degree, we know there's going to be 5 solutions. So how do we solve an x cubed minus 1? Well, we recognize that that is a difference of 2 cubes. So the factored form of that is going to be an x minus 1 times x squared plus a x plus 1 equals 0. Now again, you are correct. X minus 1 is equal to 0. That is going to be 1 solution, which is a duplicate of the one we over have here. So we don't need to write it once. We just need to understand that has 0 exists with a multiplicity of 2. But over here, we need to use the quadratic formula. So x is going to equal opposite of b plus or minus the square root of b squared minus 4 times a times c, all divided by 2 times a, which is 1. So in this case, a 1 squared minus 4 is a negative 3. Square root of negative 3 is going to equal to a negative 1 plus or minus I square root of 3 divided by 2. So I have 2 solutions here. I have a third solution. So I can have this. I have negative 1. And then I have 1 with a multiplicity equal to 2. 1, 2, 3, 4, 5.